And so the PageRank code, let me get the picture of the PageRank code up here. Here's the picture of the PageRank code. And so the PageRank code has 4 chunks of code that are going to, 5 chunks of code that are going to run. The first one we're going to look at is the spidering code, and then we'll do a separate look at these other guys later. So the first one we'll look at is spidering. And again, it's sort of the same pattern of we've got some stuff on the web, in this case web pages. We're going to have a database that sort of just captures the stuff. It's not really trying to be particularly intelligent, but it is going to parse these with Beautiful Soup and add things to the database, okay? And so then we'll talk about how we run the PageRank algorithm and then how we visualize the PageRank algorithm in a bit. Now, the first thing to notice is that I've got to put, I put the Beautiful Soup code in right here, okay? So this is, you can get this from the bs4.zip file. There might be a README, no, but there's a README somewhere. But you got to use Beautiful Soup, you got to put this bs4 zip, or you have to install Beautiful Soup for your stuff. So I provide this bs4.zip as a quick and dirty way if you can't install something for all of the Python users on your system. So that's what it's supposed to look like. You're supposed to have it unzipped right here in these files, and I don't know what dammit.py means. That came from Beautiful Soup. If you look, it's in their source code. So I'm not swearing. It's Beautiful Soup people are swearing. I'm sorry. I apologize. Okay, so the code we're going to play with the most is, in this first one, is called spider.py. And, you know, we're going to do databases, we're going to read URLs, and we're going to parse them with Beautiful Soup. Okay? And so what we're going to do is we're going to make a file. Again, this will make spider.sqlite, and here we are in PageRank, and else-l. Spider.sqlite is not there, so it's going to create the database. We do create table if not exists. We're going to have an integer primary key because we're going to do foreign keys here. We're going to have a URL, and the URL which is unique, the HTML which is unique, whether we got an error. And then for the second half, when we start doing PageRank, we're going to have old rank and new rank, because the way PageRank works is it takes the old rank, computes the new rank, and then replaces the new rank with the old rank, and then does it over and over again. And then we're going to have a many-to-many table, which points really back. So I call this from ID and to ID. We did this with some of the Twitter stuff. And then this webs is just in case I have more than one web, but that really doesn't make much difference. Okay, so what we're going to do is we're going to select ID URL from pages where HTML is null. This is our indicator that a page has not yet been retrieved. And error is null, ordered by random. And so this is our way, this long bit of stuff. And this, not all this SQL is completely standard, but this order by random is really quite nice in SQLite. Limit once is just randomly pick a record in this database where this true is true, and then pick it randomly. And then we're going to fetch a row. And if that row is none, right, we're going to ask for a new web, a starting URL, and this is going to fire things up, and we're going to insert this new URL. Otherwise, we're going to restart, and we have a row to start with. And otherwise, we're going to sort of prime this by inserting the URL we start with, and insert into it. If you enter, it just goes to drchuck.com, which is a fine place to start. And then what we do is what this does is its PageRank is it uses this webs table to limit the links. It only does links to the sites that you tell it to do links. And probably the best for your PageRank is to stick with one site. Otherwise, you will just never find the same site again if you let this wander the web aimlessly. And so I generally run with one web, this should be probably called websites. And I pull in all the data, and I read this in, and I just make myself a list of the URL, the legit URLs, and you'll see how we use that. And the webs is what are the legit places we're going to go? Because we're going to go through a loop, ask for how many pages, and we're going to look for a null page. Again, we're using that random, order by random, limit 1. And then we're going to have we're going to grab one. We're going to get the from ID, which is the page we're linking from, and then the URL. Otherwise, there's no unretrieved. And so the from ID is when we start adding links to our page links, we got to know the page we started with. And that's the primary key. We'll see how that primary key is set in a second. So otherwise we have none. And we're going to print this from ID, the from ID and the URL that we're working with. Just to make sure, we're going to wipe out all of the links because it's unretrieved. We're going to wipe out from the links. The links is the connection table that connects from pages back to pages. And so we're going to wipe out. So we're going to go grab this URL. We're going to read it. We're not decoding it because we're using Beautiful Soup, which compensates for the UTF-8, and so we can ask. This is the HTML error code, and we checked that 200 is a good error. And if we get a bad error, we're going to say this error on page. We're going to set that error. We're going to update pages. That way we don't retrieve it ever again. We basically check to see if the content type is text HTML. Remember, in HTTP you get the content type. We only want to retrieve, we only want to look for the links on HTML pages. And so we wipe that guy out. If we get a JPEG or something like that, we're not going to retrieve JPEG. And then we commit and continue. And so these are kind of like, oh, those were pages we didn't want to mess with. And then we print out how many characters we got and parse it. And we do this whole thing in a try except block because a lot of things can go wrong here. It's a bit of a long try except block. Keyboard interrupt, that's what happens if I hit Control-C at my keyboard or Control-Z on Windows. Some other exception probably means Beautiful Soup blew up or something else blew up, and so we indicate with the error equals -1 for that URL so we don't retrieve it again. At this point, at line 103, we have got the HTML for that URL, and so we're going to insert it in, and we're going to set the page rank to 1. So the way page rank works is it gives all the pages some normal value, and then it alters that. We'll see that in a bit. So it sets it in with 1. We're going to insert or ignore. That's just in case this pages is already the pages is not there, but and then we're going to do an update, and that's kind of doing the same thing twice, just sort of doubly making sure if it's already there, this or ignore will cause this to do nothing, and the update will cause us to retain it, and then we commit it so that if we do selects later, we get that information. Now this code is similar. Remember, we use Beautiful Soup to pull out all the anchor tags. We have a for loop. We pull out the href, and you'll see this code's a little more complex than some of the earlier stuff because it has to deal with the real nastiness or imperfection of the web. And so we're going to use URL parse, which is actually part of the URL lib code. And that's going to break the URL into pieces. Come back. We use URL parse. We have the scheme, which is HTTP or HTTPS. If it's this solves relative references. This solves relative references by taking the current URL and hooking it up. URL join knows about slashes and all those other things. We check to see if there's an anchor, the # at the end of a URL, and we throw everything past, including the anchor, away. If we have a JPEG or a PNG or a GIF, we're going to skip it. We don't want to bother with that. We're looking through links now. We're looking at all the links. And if we have a slash at the end, we're going to chop off the slash by saying -1. And so this is just kind of nasty choppage and throwing away the URLs. But we're going through a page and we have a bunch that we don't like, or we have to clean them up or whatever. And now, and we've made them absolute by doing this. It's an absolute URL. This is just, you write this slowly but surely when your code blows up and you start it over and start it over and start it over. Then what we do is we check to see through all the webs. Remember, those were the URLs that we're willing to stay with, and usually it's just one. If this would link off the sites of the sites we're interested in, we're going to skip it. We are not interested in links that leave the site. So this is like link that left the site, skip it. But now we finally, here at page line 132, we are ready to put this into pages, the URL and the HTML, and it's all good, right? And that one's going to be null right there because we haven't retrieved the HTML.